All right, so we're gonna look at question 2, 3, and 4 from the 9-3 worksheet. So we'll start with question number 2. Identify the limiting reactant when 4.68 grams of Fe reacts with 2.88 grams of S to produce FeS. And so, if you remember in class, we talked about, this is a little bit different than the ones we looked at yesterday because you're given two numbers to start with, not just one. And so remember, limiting reactant is the reactant we run out of. There it goes to 0, then that means the excess reactant is the one that's left over. And so here we have to still write a balanced chemical reaction. And so we're looking at Fe is reacting with S to produce FeS. Pretty straightforward there. It's already balanced, so we don't have to do anything to balance it. And then we can make our BCA table. Remember, you have 0 of your product before the reaction has occurred. Remember, for our change, it's minus on the left, plus on the right. It's just minus x and plus x because all the coefficients are 1. And then we have to take our numbers and we have to convert them. So we can only put moles in the table. So I have to take the 4.68 grams of Fe, and we're gonna have to convert that to moles. And the molar mass is 55.85. And then we're gonna do the same thing for sulfur. I'll go ahead and write it now just to save time. And so we can solve for the moles there. So 0.0838 moles of iron, and I got 0.0898 moles of sulfur. And so we can plug those numbers. 0.0. We can plug those in to our table now. And so then the key here in limiting reactant questions, or in questions where they give us two starting numbers, you got to figure out which one of these is going to run out first, or which one's going to go to 0 first. We're not going to put a 0 for both of them here. So what we have to look at, and we notice that they're changing at the same rate. So minus x, they're changing at the same rate. And so I'm going to run out whichever one is the lower number. And so I'll say that I'm going to run out of Fe first. And so because this column is completely filled in, we can now solve this for x. And I can say that 0.0838 minus x equals 0. We know that x equals 0.0838. And now, so we think that this is the limiting reactant. Remember, limiting reactant is the one that goes to 0, the one that we run out of. To double check it, all we're going to do is we're going to plug x, what we got here, back in. So 0.0838. Now, what is this minus this? That's going to equal whatever this is here. So 0.0898 minus whatever x is, which x is 0.0838. That gives me 0.006 moles. Now, because that's a positive number, we know that we picked the right one to go to 0. So because this goes to 0, we would say that the limiting reactant is Fe. And because the question only asked us for the limiting reactant, we can stop there, right? We said the limiting reactant was Fe, and we're good. So that means your excess reactant is sulfur because you have some of it left over. But again, the question asked for the limiting reactant, and we're concerned with Fe. And so we can follow the same process for number 3. So I can look at number 3. Again, we need a balanced chemical reaction. And so we're looking at the reaction when magnesium hydroxide reacts with HCl. And that's going to form MgCl2 and water. And remember, when we're writing water in the formula or in the equation, sometimes it's easier to leave it as HOH for balancing. Because you can see an OH here and OH here, you see H here and H here. It just makes it a little easier to count how many of each you have. And so I have 2 OHs here. I put a 2 there to get 2 OHs, but that gives me 2 hydrogens. So I put a 2 here to get 2 hydrogens. That's 2 chlorine. I have 2 chlorine there, and then magnesiums are balanced, so we're good there. And we can go ahead and make our BCA table. Again, you're given grams. So what do you have to do first? You have to convert the grams that you're given in the problem. You have to convert to moles. So I'll convert the grams of magnesium hydroxide into moles. And I will convert the 12.84 grams of HCl and I'll convert that into moles. And I'm going to take a second to find what is the mass of magnesium hydroxide. I got 2 oxygens, I got 2 hydrogens, and 1 magnesium. I'm getting 58.31. Again, you might get something slightly different, but that's okay if you're rounding your masses off to a little bit different numbers than I am. And here I'm getting 0.1007 and 12.84 divided by 36.45. I'm getting 0.35, we'll go 0.352. Okay, so remember, again, 0 here. You always have 0 of your product before you start. Change, we can go ahead and fill in minus x, minus only 1 because it's a 1, minus 2x because it's a 2, plus x because it's a 1, and plus 2x because it's a 2. Remember, it's minus on the left, plus on the right. You lose what's on the left to gain what's on the right. And then I can fill these numbers in. And so you can look here, this is a little different than the first one because when we look here, it was pretty easy because it's the same change and we can look at the numbers. Here, we're looking a little bit different. You have 0.1 here and you have 0.3 here. You could start here and say that's going to go to 0 because it's a smaller amount. That's not always the case, but that's a good place to start. So let's start with this saying that's 0. We'll just pick one. So we'll say we think that this reactant's going to go to 0, so let's solve for x. Now, again, if we can plug x into here and get a positive number, then that means that's our limiting reactant. So let's see what we get, 0.1007. So I'll do 0.352 minus 2 times x, which we know is 0.1007, and let's see what we get. So 0.352 minus, so I'll do 2 times 0.1007, and I'm getting that we get 0.1506, and I'm getting a positive number. So because that's a positive number, we're good. If this were a negative number, then that means you picked the wrong one to go to 0, and then you have to erase that and then make the other one go to 0. But because that's a positive number, then that means we picked the correct one. And so we know that the limiting reactant, or remember the limiting, or the one that runs out first, is going to be MgOH2. And so then that would be our answer there for number 3. And so we can move on to number 4. So I'll just flip over my paper here. Make sure we can still see it. And then our last one here we'll look at, number 4. Identify the limiting reactant. So again, we need to balance the chemical reaction. So we'll start with writing the equation. So we know that AgNO3 is reacting with NaCl. And it's going to form NaNO3 and AgCl. So set up your BCA table. What's the limiting reactant here? So again, we can start here, 0. I don't know how much of that I have. Or, well, no, we know we have 0 of that because we have 0 product before the reaction occurs. Now, luckily for us, this equation is already balanced, so that's good. So that's just minus x, plus x, plus X. Very good. Now we got to convert grams to moles. So use the numbers they give you in the problem. So 6.25 grams of AgNO3. I know grams of AgNO3 goes on the bottom to cancel out the grams in 1 mole. And I'm given 4.12 grams of NaCl. Grams of NaCl on the bottom in 1 mole. So let's find the molar mass of those two. I have, let's see, 16 times 3. So for AgNO3, I got a mass of 169.87. And for NaCl, 58.44. So we can convert those to moles. And so once you have those in moles, we can then plug them into our table. And so 0.0368 and 0.0705. And so here you look, okay, it's the same change, so this will be easy. Which one of these is the smaller number, 0.03 or 0.07? Well, I know 0.03 is a smaller number, so I have less of that, so I'm gonna run out of that first. To double check, we can solve for x, 0.0368 minus x equals 0. X equals 0.0368. Let's plug this in and make sure we get a positive number there. And we do, and I'm getting 0.0337. So because of that, we know that that's our limiting reactant. So we know that's the one that went to 0. It ran out first. And so we say the limiting reactant is AgNO3.